Welcome everyone to Index Office Hours 62. Today is the 24th of May, and I'm very excited to invite you all to today's Index Office Hours. So we have a jam-packed agenda as always, and for all of those who are here with us, we will give you a POAP at the end, and this time the secret word definitely works. I have double checked, and so I'm very excited to share that secret word at the end of today's episode. So without further ado, let's jump straight into opening remarks. So as always, we do a big shout out to 𝗨𝗂𝗧𝗧, and this week's episode was episode 65 with Vanessa Grillet. She recently moved to 𝗨𝗀𝗧𝗧𝗧 Ventures, if that's how you can pronounce it correctly. She is a prominent figure in the Web3 space, also an ex-Consensus team member. So, you know, I was also ex-Consensus, so it was nice to hear her on the podcast, a fellow friend. So she basically shared her perspective on the crypto adoption curve and how she due diligences Web3 projects, as she's now an investor via the venture fund, and then she spoke a bit about the graph and the future of Web3. So if you're anyone who has an entrepreneurial knack and are looking to potentially raise money in the near future, I would highly recommend listening to that podcast so you can get that perspective on venture, on Web3, from a venture capitalist perspective. So that is the first item. The second item is Graph Day. I can see many of you in the chat who have Graph Day as part of your names, which is very exciting. It's happening on June the 2nd. Very, very close. Tickets are only $100. So if you haven't got your tickets already, please do grab them. I mean, this is the best time to do it. There's going to be some of the most intelligent people in the Web3 and Graph ecosystem right there in person in San Francisco, and it's going to be a lot of fun. So yeah, make sure you're there. There's also a hackathon happening from the 3rd to the 5th of June. Again, are going to be an incredible opportunity to hack on Web3 related topics, graph related topics. So yeah, make sure to attend. So there it is. That is opening remarks. Thank you all for listening. And without further ado, I'm going to hand over to Anna.
Thank you, Abel. Okay, so hello everyone, and welcome to our regular segment Repo Watch. As always, you will find links to release notes and PRs in the agenda. And before we start with major blockchain clients, I want to remind you that we recently have updated the flow to only mention the clients that have had new releases. All other repos will still be found on the agenda with details on their last release version. Another quick reminder that recently 𝗨𝗀𝗀𝗀𝗀 has started releasing two versions. So version 1 or beta versions, and version 2 or alpha versions. If you are looking to migrate from 𝗨𝗀𝗀𝗀𝗀 1 beta version to 𝗨𝗀𝗀𝗀𝗀2 alpha versions, you will need to sync from scratch as the data models are no longer compatible. Similarly, the Streaming Fast team has started supporting both Ethereum block version 1 and 2. So please be aware that Streaming Fast get versions that end in FH2 are for Ethereum block version 2 and are not currently production ready. And now that we've finally finished the reminders, looking at major blockchain clients, we've only had new releases from 𝗨𝗀𝗀𝗀𝗀 version 2 or 𝗨𝗀𝗀𝗀𝗀𝗀 alpha. So here we have had version 22.05.05 alpha, which including reduced network traffic consumption, reduced memory footprint for Borg consensus code, a new feature in Sentry that allows for detecting node IPs addresses using STAN protocol, various fixes for POS transition, and a reduced memory footprint of using block snapshots by using more compact half-man decoding tables, and a fix for ETH fee history to be able to work with block snapshots. We've also had on 𝗨𝗀𝗀𝗀𝗀𝗀 version 2, version 2022.05.07 alpha, which fixes POS transition that was broken in the previous release, fixes some panics to do with the header downloader that were also introduced in the previous release, and just allows block snapshots for BOR, for Mumbai testnet and mainnet, but that is not enabled by default. This is all we have today for major blockchain clients. So before I tell you that we have no new releases on the graph stack, has anyone tried to use these 𝗟𝗂𝗧𝗧 versions that we've just spoken about? I'm gonna take that as a no. Okay. And has anyone had any issues with any of the major blockchain clients ongoing for the last week or so? Okay, I will take that as a no. As I said, GraphStack, we have no new releases. So that's it for me, very light on RepoWatch this week. Over to you, Abo.
Thank you so much. So this is going to be a new one for me. I don't usually cover Protocol Watch. It's usually Juan or Chris, but yeah, it's going to be me today, so let's do this. So I'm going to kick off by talking about forum governance. There is a GRP, and I'm going to hand it over to 𝗨𝘀𝗀𝗃 to tell us more about that GRP.
Thank you, Abel. Me and Mac posted GRP 0001 in the forums. It's a collection of 3 features that will improve the subgraph developer experience by allowing them to have more utility and more flexibility when they create their subgraphs. So it's 1, an initialization handler that runs once when a subgraph is published. And that allows subgraph developers to hydrate the store with data they have added to the mapping files or on IPFS. It also allows for some much cleaner patterns when they, for example, initialize the dynamic data sources. The second feature is cron jobs and filters. These allows subgraph developers to indicate that a certain handler or a block handler, a call handler, or an event handler is only going to be run every so often, and that can lead to massive performance improvements in the case where the subgraph developer doesn't need that handler to be run every single time there's a trigger. And then the third one is Decorative Hooks, and that allows subgraph developers to indicate that at a certain time or a certain block number, a piece of code will be run, and that allows them more flexibility to change an entity, they can give like a timeout for an entity. They can make it so that then at a certain block number, a code is run and an ETH call is run, for example. This could be useful for NFTs that aren't revealed when they are first minted, and a lot of other use cases as well. Yeah, so I believe that will improve the subgraph developer experience. So giving it back to you, Abel.
Amazing. Thank you so much there, 𝗨𝘀𝗀𝗃. That was a pretty good description of the GRP, so appreciate that. So swiftly moving on to contracts. So very minimal updates. I will highlight 2 in particular. One of them is 574, and that is in relation to verifying contracts via Sourcify. So the key aspect here to zero in on is Etherscan has a huge database of ABIs which are related to contracts, and a lot of people verify their contracts via Etherscan, which is, great, but, Etherscan owns all of this data, and that isn't the most optimal, in my opinion, and I think for most other people, state for this kind of new world of decentralization that we're aspiring towards. And so Sourcify is this new project, relatively new project, that allows people to verify contracts, in an open source fashion. I believe that Sourcify open sources everything, and so you're able to see everything, and there's no that proprietary, those ABIs aren't proprietary data of Etherscan. So yeah, it's great to see that we're now verifying our contracts using Sourcify. The next one is 571, which is the very exciting move towards Arbitrum. So as we mentioned in previous IOH episodes, we are experimenting with Arbitrum as a potential layer 2 for the graph, and this is a new experimental release to kind of move some of the features over to Arbitrum. So again, very early days. I believe that in the PR it says, let's have a look what it says on the PR. Work in progress, very early exploration. Please take with a bucket full of salt. So that should give you an idea of how early this thing is. But yeah, very exciting nonetheless. So there you have it. That's everything for Protocol Watch. Not much. So without further ado, I'm going to hand it back to Anna to take us into the Fireside Chat.
Thank you, Abo. Okay, so this is my first Fireside Chat, so please bear with me. But today we have a few people joining us. So we have Hope, Ford, Sam, Alexis from Figment, EdgeNode, Semiotic, and myself from GraphOps. And we have joined to talk about Indexer Experience Working Group. As a reminder, this is part of our larger series of covering the Graph protocol and roadmap, and this is the last section. So first things first, I'd like to ease into this Fireside Chat by asking Ford, what is the main focus of the Indexer Experience Working Group?
So as the name implies, the Indexer Experience Working Group is all about developing software around and infrastructure components and education materials to support the indexers. And yeah, maybe that sums it up. I could get into more details, but I imagine your questions will get us there. So
yes, so the follow-up question to that was what specific outcomes or initiatives is the Indexer Experience Working Group trying to accomplish in the context of the published research and development roadmap?
yeah, so I would say that the focus of this working group has maybe three major buckets. One of them is automation tooling. And we have a few things that are actually going to be released for testing in the next week or two around automating some of the decision-making processes for indexers, automating allocation decisions and cost model creation. And then another bucket is infrastructure. So providing Kubernetes manifests, Docker files, and supporting your infrastructure, especially as we move to a multi-chain world and the indexer stack gets even more complicated. And then managing the indexer agent and education materials is another bucket.
Thank you very much, Ford. So just before we dive into every single one of the different buckets you've mentioned, we have a more general question for you, Ford, which is indexers have been awaiting for the 0.19.text branch for indexer repo for some time now. And looking at the repo, version 0.19.2 is marked as a stable release. But if you actually look at networks.md on the repo, it still recommends 0.18.6 for mainnet use. So just before I ask my question, just to remind everyone, the list of changes since version 0.18.6 include introduce rate limits for indexer service endpoints, added logger improvements and more metrics to indexer agent, added live metric for operator, EAT balance for both indexer agent and indexer common, added CLI test harnesses for indexer CLI and indexer common, support for indexing rules, batched voucher redemption, upgraded graph protocol cost model, and introduced the indexer native component. So that's a lot of changes. So the question is, Ford, what do you think are the remaining steps to get us to version 0.19.2 to be stable?
Yeah, so I think we're really close. It's I think the software is stable. It's just there's been a lot of changes in the way the compilation building process works. And there's a few remaining items there. Namely, as far as I know, just that the Docker files are currently not, the images that we post on the repo are currently not working correctly with the base image that has been used in the past. So there's a small update being pushed through to make those Docker images work. And then as far as I'm concerned, that people should start using it.
So that's great news. So we're very close. So what you're saying, the software is stable, but we're just improving a few things on the Docker image layering.
Yeah, exactly.
Awesome. Thank you. Okay, so moving on to one of the first buckets that we're going to cover today, which is Allocation Optimizer. So here I want to start by asking Hope, who's been working on the Allocation Optimizer, what is the objective of releasing an automated Allocation Optimizer, Hope? I can't hear you if you're speaking. I can see you're not muted, but I can't hear anything. Can anyone hear me?
Yes.
Okay.
Yeah, loud and clear.
All right. So I think Hope has technical issues for now. Alexi, would you be okay to respond to this question? So what is the objective of releasing an automated allocation optimizer?
So what we've observed a few months ago is that some very large indexers have been moving a very large amount of stake to subgraphs that are that already have. Oh, Hope we can hear you now.
Oh, interesting. Sorry.
Okay, I'll leave it to you. You know better that subject.
Yeah, so I think for a lot of indexers, I'm pretty sure they already have some sort of optimization tool. I know people are using Excel sheets or Python notebooks or any module that sort of solve the optimization problem. And so the idea for writing a automated tool that sort of integrate with the rest of the indexer stack, we think it would sort of take a lot of time away from the actual operation part of the indexer, a lot of the repeated effort that we sort of have to run each time we do allocation cycles. And so doing this, we sort of provide a default optimization for all the indexers so that this is not to force people to use anything at all. This is just to provide a really convenient way for people to manage allocations. And we are really waiting for force action queue functions to integrate together so that in the future, what we are envisioning is indexers can sort of set their preferences and sort of just monitor the allocation cycles instead of doing them manually or running separate things all over the place. So that's the idea.
Thank you, Hope. And one thing I picked up from what you said was that this is not a mandatory, like it's something that you opt in rather than something that you'll be forced to use with something that you'll be forced to use. So just a follow-up question on that, and this one is for Sam. So from a protocol economics point of view, this would seem to have a material impact on the competitive landscape by removing an existing competitive element. What do you think of that, Sam?
Yeah, that's a great question. One of the things, so at a high level, one of the goals that we have in protocol economics is we want to design or even update mechanisms that exist in the protocol so that optimal behavior from participants in the protocol lead to, like when we look at individuals' optimal behavior, it leads to optimal health of the overall protocol. And so we have that kind of that high level goal of actually making the rules of the protocol such that when individuals optimize for themselves, the protocol itself is running as best as we can get it to run. And so part of how we're going to go about doing this is that, well, I guess related to that goal is that we also want to provide tools for users in the protocol so that these tools can help people that are using the protocol behave or make optimal decisions for them, so that things are just, there's a lower burden on everybody who's using the protocol. And so with this allocation optimizer, what this thing does is it's going to, when an indexer uses this tool, it's going to look at the opportunities available given the current signals on all the subgraphs, and it's going to tell the indexer, here are the best opportunities for you, and they would get the same result if they were to try their best to pick their own signal. And something that Alexi said earlier, how does this help us? How does this help the state of the protocol? Well, there was, a few months ago, there was what we call the lazy whale problem, where there was a large indexer who was making suboptimal, even for themselves, suboptimal decisions, and they were allocating huge amounts to subgraphs that were already over-allocated. And if this lazy whale would have instead just had to have pressed a button and just executed the built-in indexer allocation tool, the lazy whale would have maximized their profits, and it would have been better for the overall health of the protocol.
So, so what you just said, pretty much all of it makes sense to me. I'm not 100% clear on how it is better for the protocol health.
Well, one of if we have a big indexer, let's say, over allocating, then what that does is in those cases, it caused all the other indexers to have to, when the well over allocated, allocated to a subgraph that was already over allocated, then the other indexers who were more responsive than the lazy whale, who wasn't going to do anything, all the other indexers had to scramble, and they had to pay gas, and they had to leave and go readjust their allocations. And so really what that is that's an inefficiency in our market, and it's adding extra cost to all of our indexers and also extra frustration to all of our indexers. And so in that sense, it's negative for the protocol. And actually, at this point, I have to drop off the call. I have a previous thing I have to do.
No worries. Thank you very much. Actually, everything now I understand fully. I understand how it affects everyone in the protocol and why we should strive to use an allocation optimizer. So thank you for joining. That's mainly what I needed from you. I'm just gonna continue moving on. Also talking about the allocation optimizer. So I had the chance over the weekend to set it up, and I found the instructions super straightforward. Hope, my question to you is, well, first of all, I was excited to use the Julia stack for the first time, but I couldn't help but wonder, why did we choose to write the allocation optimizer in Julia instead of Python?
So this was pretty much, at first we were definitely deciding between Julia and Python. The reason we went with Julia is because it's faster than Python when we are trying to load a lot of data in, and it takes a little bit less memory than Python do, so it's lighter weight, and it also has pretty good compatibility with other languages, so it can use external libraries that are in Python or in C or Rust. And it already has a lot of built-in libraries for optimization algorithms, as well as some machine learning algorithms. So this is just more of an interesting thing that we decided to go with the Julia route. And I also know that there are existing Python optimizers.
Thank you very much, Hope. So before we move on to the automated cost models bucket, I'd like to open this to the stage to see if anyone has any questions related to what we've been discussing so far and the allocation optimizer. Okay, in that case, I will move forward to automated cost models. So we know that most indexers don't want to write Agora cost models by hand. So the guys of Semiotic have done research on machine learning use to predict the cost of GraphQL queries. So that research resulted into a short-term solution called automated Agora pricing, or AutoAgora, to predict more efficient costs per queries. So Alexei, can you please describe at a high level how AutoAgora works?
So yeah, thanks for presenting it so well in such a concise way. I wouldn't have done it better. So yeah, pretty much what it's doing is that it is there are two aspects to it really. One problem is, how do we determine how some queries are more expensive than others? So our main long-term work is on the machine learning model, but a shorter, an easier way to get to a pretty good result is to just look at the history of served queries for an indexer, and just look at, for example, the most frequent queries. And for these, you would look at the execution times that you've observed on your own stack. And you just do very basic statistics to determine that some, what we call query skeletons, which are queries without any values in them, some query skeletons are more expensive than others, right? Just by computing the mean of the execution times that we've observed. So that's one aspect. In particular, so it's not striving to be extremely precise, but at least we can kind of, we can make the difference between some queries that take 1 or 2 orders of magnitude, more resources to execute than others. So that's really the goal, is to, make subgraph consumers pay for very very expensive, very badly formed queries. The second aspect, however, is that we want to follow the current market price. So that's not obvious. So we do so with that previous system. We just know that let's say a query is twice as expensive as another one. However, what should be our, let's call it, base price? And so that's a little bit of it's a little bit of a harder problem to solve. And for this, we decided to use some machine learning. The idea overall, though, is pretty simple for those who took the time to try and, even with a flat cost model, to try and adjust their prices to get the most bang for their buck. The idea is that you poke around, you try different prices, and you look at how many queries you're receiving. And really, the sweet spot, especially for a flat price model, would be you're maximizing your base price multiplied by the number of queries per second, such that you maximize your revenue, right? Your GRT per second. There's multiple, you could think of very simple algorithms to solve that problem, but the problem is that if you have a simple algorithm, something naive, you will eventually converge to a certain price, but the market price will move most certainly over time as there's more or less indexers coming in and more or less consumption. And the problem is, when do you decide to actually start exploring again and trying to find a new optimal point? This in machine learning is called, in reinforcement learning, is called the exploration versus exploitation problem. To solve this, well, because there's many solutions now, thanks to all the progress in reinforcement learning that's been done in the last decade, we decided to use a simple model that's called a continuous bandit, which is its goal is really to just poke around and test values and then try to optimize the next values it will sample in such a way that it still explores a variety of values, but most of them will be close to the optimal point. So you still get an idea of the shape of let's say the queries per second function, but you're remaining pretty close to the optimal point. So even as you're exploring, you're also exploiting that optimal zone, right, for your pricing.
So so just to clarify back at you, just to make sure I understood everything you said right. So so two things. First of all, I remember when I was reading about this automated cost model that the way the research has been done, the tool does not assume any cost to begin with, so everything is computed. And what I'm understanding from what you just said there, by using the machine learning reinforcement, and I'm not a machine learning person, so I don't know much, but basically the way the system works compared to a more naive system, more static system, is that it updates to where the protocol is going and how the market is growing as well. Would you say that's correct?
Yeah, it's a balancing act, right? You're balancing balancing, trying different prices to see how things change in terms of your revenue per second, versus not trying values that are too far away, because for these, you can try them, but you're gonna get like lower revenue or lower queries or something like that. So the goal is really to balance it, and yeah, it's not trivial to do that with a naive solution.
Thank you. I see. And as an indexer, how do I take advantage of this tool? Where does it fit? How do you integrate it? Stuff like that.
So we're planning to release an open beta, hopefully. I have I set a random date of Graph Day to get it done. There's quite a lot of engineering involved, but here's pretty much how it works. So we are collecting for the full system. We're collecting all the queries that are run, and so we get that from the logs of the indexer service, and we pre-process those queries by normalizing them, and then saving them into a database that we use as a database of the logs of all the queries that were run. That normalization step, by the way, is separating the query skeletons that we're seeing, because we've observed that most of the queries, they're just repeating, right? And so we have basically two tables, one with the query skeletons and another one that's referencing the query skeletons and also providing the values and saying it, exactly at which time we process that query and how much time it took to execute that one, etc., etc. So that's what I call the 𝗨𝗂𝗧𝗧 processor. Then we have another piece of software that is regularly updating, so checking which query skeletons are seen most often, and computing the mean of the execution time, which can sound a bit naive, as a cost model, but it's a start. Anyway, so it does that, and then it just builds the Agora model automatically by dropping those query skeletons and setting them to pretty much the mean of the execution time times a price multiplier. So that's what goes into the Agora model and gets sent to the indexer agent automatically. Another component is the continuous Bandit, the reinforcement learning model. And what this does is that it is looking at the number of queries per second that we're observing for each subgraph by extracting that information from the Prometheus the Prometheus metrics of the indexer service, and it then adjusts the variable that we have in that Agora model that we set earlier for each of those query skeletons, that price multiplier, and just tries values and waits a little bit for the gateway to take into account the new value, and then we just measure for 1 minute what's the average queries per second we receive after picking that value. And for the Bandit, it's just like rinse and repeat, right? You just continuously try new values and measure how many queries per second you receive, and the reward for that reinforcement learning model is that queries per second times price multiplier. You want this to be as high as possible, which means highest revenue per second possible. So yeah, that's pretty much how it works.
Thank you very much. That was a very detailed overview. I personally am looking forward to trying this tool. I'd like to ask the stage now if you have, based on everything Alexi has said, if you have any follow-up automated cost model questions.
Yeah, so I've just invited Tim to the stage. I'm assuming he has a question, so maybe Tim, if you want to ask your question.
Good day. Yeah, I did have a question, but I already asked in the stage chat. I had a question about the lazy well thing you talked about earlier, Sam talked about, but I already got an answer, so it's fine. Thank you very much, though.
Amazing. That's good to hear. Yeah, open floor for anyone who has questions on the stage, and also if anyone in the audience wants to raise their hand, I'm happy to invite you onto the stage to ask your question.
All right. In this case, I'm gonna move on to the last bucket, the most exciting one for me, which is orchestration, automation, and infrastructure. So just to give you a bit of an overview, we are focusing on adopting automation and orchestration tools with the purpose of better managing the life cycle of serving queries and maintaining the underlying infrastructure. So the long-term plan is to make smaller indexer operations more economically viable, to help indexers run a highly available and more secure setup, which would result in dApps that are more confident in indexer reliability. So, as part of this plan, we are looking to move to a more cloud-native infrastructure stack that allows for ease of scalability. So, today, as a small indexer, you are likely deploying your stack on a single node machine. By using Kubernetes and Helm charts, Helm charts are packaged templated units of Kubernetes resources that can easily be redeployed and upgraded while still maintaining state. So by using Kubernetes and Helm, we will enable new indexers to deploy the indexer stack on one machine, and as their operations grow, they will be able to add more nodes to their Kubernetes cluster and easily scale without downtime. And as Ford said, in addition to the nature of the indexer stack, the nature of the indexer stack is evolving in such a way that in the future you will need to run multiple nodes due to the need of having to support multi-blockchains and also a firehose-centric stack. So one question that comes to mind when talking about orchestration, automation, and infrastructure is a lot of people get intimidated when they hear Kubernetes. It's a very complex ecosystem, and whilst it's really easy to set up a cluster using GCP or AWS managed offering, it is unrealistic to ask indexers to sign up with additional cloud providers, especially when a lot of them run nodes on bare metal. So it's unrealistic to ask them to do that just to get a managed Kubernetes offering. So a valid question would be, do we really need Kubernetes? And before I ask the rest of the group to contribute here, I'd like to give my own answer, which is probably not. We probably don't really need Kubernetes. And in fact, most tools, like you can create your own, you can do so many things. But the longer answer is we are looking at a flavor of Kubernetes distribution that is open source software and that can be used on both public, private, and or bare metal. So we would not ask any indexer to sign up with a cloud provider just to get Kubernetes. And whilst we could stick to the Docker Compose setup that Payne has come up with, which, by the way, it looks great, and I know a lot of people have been relying on it, it does have a few shortcomings, and the main one is that it doesn't really scale easily to more nodes. So the good news with indexers being set up with the Docker Compose stack is that you already have the basic knowledge on containers when moving to Kubernetes, so you're not starting from scratch. Another thing is that Kubernetes has come a very, very long way since I personally started using it, which was probably 6 years ago, where none of these open source distributions existed. So, and if you're wondering how will we support indexers in bridging the knowledge gap to move towards Kubernetes, we do plan to provide demos, workshop, possibly interactive environments, and just do overall knowledge sharing from a bunch of us in the Indexer Experience Working Group. That's what I have about orchestration and infra, and I'd like to ask Ford if he wants to add anything to what I've already said, in terms of what we're trying to achieve, and then also to ask people for questions.
Yeah, I think that was a great summary. I mean, one question I would ask is how you think you're preparing for and what it might look like when we move to multi-chain. Specifically, I know you might have been working on some work for helping orchestrate Ethereum clients and managing them.
Yes, I would think that would probably with the use of Helm, we would be writing all of these basically charts for. You'd have multiple components that create the stack of, let's say, one blockchain. Those components would be split in Helm charts. The Helm charts are packaged Kubernetes resources. So I would assume would have different stacks for different blockchains. And at this point, I don't know for sure if any of those components would be shared between the different chains. But yeah, that's how I see it.
Yeah. I think a lot of the components can be shared. Like Graph Node is built to work on multi-chain. The indexer agent and components will need an update, but they'll work multi-chain. And then I think one of the more complicated things is if you choose to run your own Ethereum and chain clients. So you would then have a mainnet client, a Rinkeby client, a BSC client, etc. And how do you kind of manage those? I think that moves some of the management into that area, unless you're paying for a service.
I think to manage those would not be hard at all. I can speak in detail about how you do it. So just to give an example, let's say we have a Helm chart for Ethereum, and you want to run, as you said, mainnet, Rinkeby, and all of that. So the Helm chart would contain all of the different options, but they're not set until you provide the options. So you just provide, let's say, like running Rinkeby as an option through a values system. And I can see that Nuviba is typing, and a few others. Let's see. I'm just gonna invite you to speak. Okay. Yeah. Any more questions? Anything else to add, Ford?
No, I think that's a good summary. You guys have been doing a lot of good work. I'm excited to see some of the Helm charts come out. And it seems like some people have questions. Does anyone want to come on the stage and ask about some of the previous segments we've talked about? Tim?
I'm sorry, you were talking to me?
I thought you had a question in the chat.
Yeah, I had a question earlier about over allocation, but someone in the chat already answered it for me. I don't know if anyone wants to add anything to it, but like it's all still new for me. But Sam was talking about the lazy well, and that over allocation would be negative for the protocol, and it's not entirely clear to me why that is.
Oh yeah, so Sam talked about it from the indexer perspective, which is important, but another important participant, of course, are developers that are querying the protocol. And I think that is important to note here. So if there's a quote unquote lazy whale who's over allocated and thus the incentive is very low for other indexers there, they might move off of that subgraph deployment, which could result in very few indexers actually indexing it. So maybe there's only one or two. And that just results in less resiliency for developers. If that indexer happens to go down, queries are going to start failing. And part of the incentive model on the network is to have robust resiliency on the supply side. So if one indexer goes down, there's others available. The lazy whale problem causes issues there.
That makes a lot of sense. It sounds like you want to encourage a lot of small indexers instead of one very large one, basically.
Thank you for that. And also, just looking on the stage chat, Nuviba has asked for fun which platform do indexers use, and it's A for Ansible, K for Kubernetes, D for Docker Compose, O for others. So, and bare metal. So my comment to this is you can use Ansible to install your Kubernetes distribution and just to manage your bare metal or your public cloud or whatever. Oh, and I would say the way I see things is Ansible and Terraform are comparable, and then you can do some things with Ansible that you can do with Kubernetes, but I would never compare them. And another very important point that Alexi made is that for people who voted for Docker Compose, Kubernetes is just Docker Compose on steroids. So, and we will make it easy for people to learn it. And for anyone who's on bare metal, we are not singling you out. You'd be able to use the same setup.
Yeah, I wanted to say about the multi-chain question that, mostly I've been basically running dedicated services and sort of use those as my components to spin up what I need. For example, I have mainnet in the current shape is Ethereum all the way. But for example, I use a dedicated or a standalone setup that does both BSC and Polygon, and have a server with Polygon node and another server with a Polygon node, and then a server with the indexer. I've been experimenting with putting the indexer together with the node itself. But in terms of, you can just puzzle together physical servers in various different ways. And I think we are sort of modeling after a hosted service where everything is sort of approached via a unique endpoint. But yeah, since I'm using a standalone setup, I have more margin to experiment, and basically I have BSC subdomain for the BSC subgraph, and then Polygon subdomain for the subgraphs that I have on Polygon, which makes, I potentially could tie them together with the database sharding that is there, but fully separating them on different subdomains has its advantages. And most of my stack, I have 2 BSC stacks and 2 Polygon stacks. In the case there is an issue, I can swap back and forth. So this is a very, very different way of approaching things that I have encountered in the past that have some advantages that the trying to fully integrate everything into one thing perhaps doesn't have.
So it's really hard to comment on everything you just said, Cohen, without seeing an architectural diagram or like fully getting more detail. And I'm aware that we have 1 minute till the end. So what I would say is, so it sounds to me like you want to make sure that certain components of your stack have enough resources and are not competing over resources with certain nodes. And maybe sometimes you want, for let's say node X, you only want this component to be there, and you don't want to share some resources and stuff like that. All of that you can do with Kubernetes, with like node tolerations, with like as I said, it's hard to fully comment on everything you've said, but it will be interesting to see your setup at some point if you wanna share it with us. So then we can tell you exactly how it would work, and we can keep it in mind just in case other indexers have the same setup to make sure we address it.
Yeah, from my experience with Kubernetes, I would say that Cohen's setup is the easiest way to implement it would be Kubernetes, indeed.
Thank you, Alexi. Okay, well, with that, unfortunately, we don't have any more time for any more questions. So I will have to hand it over to Abel.
Amazing. Thank you so much. Thank you so much for the section. I definitely learned a lot, and thank you everyone for your contributions. So the moment you've all been waiting for, the secret word for the POAP, it is please, all capital letters, please do not farm this POAP people. So that's please do not farm this POAP people. All capital letters, spaces in between every single word. Please do not farm this POAP people. I thought it'd be funny to use that secret word because I think last week we had some issues with the POAP, and yeah, I thought it'd be funny to have the secret word. So there you have it. Please do not farm this POAP people. That is the secret word. I hope you guys get the POAP. If you have any issues, please do mention in the stage chat or just DM me, and we can sort you out with the POAP. So yeah, enjoy the POAP, and yeah, thank you all for attending this IOH episode. I'll see you all next week. Bye.
Bye.